This
for
conference will now be recorded.
while Reddy is
Reddy,
preparing. Go ahead.
this is Durgesh. Quick question. So before we go through Reddy's material, which you sent yesterday,
Yeah.
can we just up level and see what is the goal? Are we trying to mark the hot memory or hot pages and move? What are we trying to achieve? Or we're trying to provide APIs that would be useful?
Okay. All right. Looks like there is Reddy. You have added another slide or something, I guess.
Yeah, it looks like that.
Yeah, I added a
Okay.
couple of slides. By the way, yeah, so the few of us actually met offline. Is it this week or last week? It's been like almost this week.
Yeah.
To essentially collect, get all the, consolidate all the feedback that Sabir actually got in the previous meeting and brainstorm on what is the best way for us to make traction. Right. So the goal is to essentially not overly bogged down by a very comprehensive set of specs, but rather scope it down to an extent where we can actually make progress. That was really the theme of what we talked in the offline meeting, and this is really the summary of that discussion. But Durgesh, like you said, the point is where exactly is this activity being headed? In general, the theme seems to be that we want to focus on drafting the the cloud requirements on how you can actually access the memory patterns for effective tiering. Right, that's really what we are looking for.
For CXL attached, right? Because the reason I was
CXL
asking
attached,
that question, because within the SOC or host, we have multiple things here, as you have listed 3 papers, and then there was a PhD student who also did a solution called Daemon and upstreamed it in the Linux kernel now. So there are multiple solutions which exist. So CXL, we are trying to see how we hide the additional latency because of CXL attached memory, right?
That's right. Yeah, and that probably will become more clear in the follow-on slide. But yeah, the theme is let's focus on the CXL memory buffer, and also keep the the focus to a very simplistic platform design where the memory buffer is actually attached and managed by one server, as opposed to multiple servers and the pooling and all that stuff. While that needs to be done, we thought it's probably better to start off with something, more easier to, start off with, and then start expanding that scope into more comprehensive, set of things, including different device types, different media, right? What happens if it is a bandwidth-oriented media like NVM? All those things need to be comprehended. It doesn't necessarily mean they're not important, but from the priority perspective, let's start with something simple config. Where you have a CXL memory buffer attached to the server. How can we actually make these two things work better, from the tracking perspective for effective, tiering decisions? So that's basically what I was trying to tell you in the second bullet, right? So,
but I think just to stress on Durgesh's question, the idea is the whole point is basically to start sharing now so that we can get the right inputs and expand based on the baseline, right? But also stay constrained on the requirement side rather than solution space so that people can still do their implementation without getting into the nitty-gritty and value add that everybody offers.
I think that's a key point, Manoj.
Yeah.
I mean, what is requirements? Because I think there's a slippery slope. I'm not saying between open and proprietary. There's chip companies here, the systems companies, software companies, cloud guys.
Yeah.
They have their own ways of doing things. They want to preserve something for their own.
I agree. I completely agree. Renu, this is why I saw your email and I wanted to make sure that that's captured.
So should we maybe not today take some time to define, because the CXL consortium has found a way to be the standards and define things and implementation to each companies. Something like that we may need to have.
Yeah, let's start with the requirements. Yeah. Okay.
I have that actually in the last bullet, right? So, I mean, I'm more than happy to change these things. So just tell me exactly if it's not covered, I'll be happy to add more, right? So
I,
that's really the
I,
intent of the discussion.
yeah, let's get at least through the proposal part, and then I think people can mull on it and provide inputs, right?
Right.
So this is Anant.
Yeah, no?
Good.
Two things basically, in my opinion. One is the OS level requirements, what needs to happen in operating system side, and one is the initial level on the buy side or any fabric level stuff. Correct? Those needs to be outlined for this flow to work, right? How do we distinguish those requirements and capture that?
Yeah,
Correct?
yeah. Right. Anand, give me a second. Let me cover when I go to the third slide, we can actually talk about exactly what is the best starting point. I think we are all kind of debating, uh, you know, a starting point for us to actually make the initial definition of the cloud requirements in this space. And I will cover that in the third slide. It's a very conceptual diagram, but hopefully that will address your question. Um, Okay, so there was a bit of a discussion on, hey, what is a device form factor, what type of media, and how are we going to address that? In general, at least from a starting perspective, we want to be agnostic to the CXL device form factors as part of this effort. I'm not talking about CMS overarching scope, just the memory access tracking, specific focus. We should not worry about the device form factors. We assume that there will be, wide variety of device form factors be able to support, through the interface that Samir was actually talking about in the last meeting. From the requirements perspective, we had few discussions in the FDI SDM meeting, and some of you probably did not attend that. Microsoft actually shared quite a bit of the paper related info with a lot more click down during the presentations, and so is Meta on the TPP. Um, so the theme is that we have set of requirements that are already out there that were published by Microsoft, Google, and Meta. We should actually use that as a starting point as opposed to starting from ground zero and then start refining from there, right? And then last but not least, some of this may become a standards activity. Um, Typically in OCP, we normally don't embark on the standards, but we essentially collaborate with other consortiums like CXL in this example to essentially figure out what's the best way to drive the standards. So those are the meta themes. Yeah, the feedback from last week got consolidated into different buckets, and I will go through each one of them. What I primarily would like feedback on is this we have identified few you know uh, areas where we need to use them as a starting point for the spec definition, requirement spec definition. I want to get input on if that is consistent with what you guys are thinking. So let me cover this quickly, and then I will pause to get the input. If there are missing items, I'll be happy to capture. If the priority doesn't jive well with what you have in mind, I would like to actually have that discussion as well. So the measurement, what exactly are you measuring to say that the page is actually being hot or cold, or maybe different types of hotness and coldness? It could be latency, it could be bandwidth, it could be a simple memory touch, or it could be the frequency of changes to the specific portion of the memory, right? They're all valid ways of. There are umpteen number of uh, ways to measure the access of memory region. Which one should we really focus on? So that's one specific dimension that we kind of talked last week. And then there is the granularity part. How granular, at what granularity do we really need to track? Is it a cache line? Is it multiple cache lines, or is it a page, huge page, or huge page? Is it reads versus writes? Do we really need to get down to the detail of maybe by application, right? And then obviously, there is an element of interleaving and pooling on top of that, right? So there is the physical media versus actually there is a virtual uh, mapping on top of that, right? So exactly what granularity do we want to cover? The temporal nature of the access tracking, data structures that are being stored. How long are we going to keep? Is it like a circular buffer? Is it a histogram? How exactly the device need to implement, and then what type of levels we actually modulate from the heat map perspective. Is it simply hot and cold, or are there X number of levels that essentially define the hotness and coldness and warmness, right? So that's the levels of access. There are obviously the requirements when it comes to memory access tracking. There is an element of real estate that you have to take inside the memory buffer that has implications on the power, thermal, maybe form factor impact. What does that look like? Then there is an implementation side of the story. Uh, what is the impact of adding memory access tracking inside the memory buffer from a latency perspective? And then obviously, the element is on the monitoring side. The what who does the monitoring? Is it the device? Is it the kernel? Or is it the application software? Uh, and then, is the platform, is the user level monitoring in band versus out of band, right? Or are we going to be agnostic? Um, so there are multiple monitoring entities spanning all the way from the device uh, to the operating system and the user level applications, right? That includes the platform as well. And then the monitoring path, inline, random sampling, or out of line when it comes to memory access tracking. Um, each one has implications, right? That kind of goes into more of an implementation detail. Then the media itself and the CXL memory buffer, DDR 4, 5, HBM, storage class memory, non-volatile memory, etc. Do we really need to pay attention to the type of media that the memory buffer is, packing and implementing? Uh, the interfaces, I think the standards part that you guys mentioned in the beginning. It goes without saying the security and RAS have to be comprehended as well. Even though it is a big elephant in the room, we do have to address that part. And the feedback loop mechanism on how effective the tracking has been. Is there some dynamic nature of modulating the level of access or the amount of access and all the other attributes that may be influencing the effectiveness of the access tracking. And then last but not least, we do need to have some benchmarks to be able to measure the effectiveness, right? So those were the items that we kind of consolidated and thought, from a starting perspective, let's keep this as, not focus only on the implementation side of the device. Let's assume that the device is going to implement, focus on the interfaces. This is what Samir was talking about. And then essentially Excel memory buffer as a starting point, and figure out the best way to expose and how does the OS kernel application agent can actually work together to deliver this, use this data for effectiveness of the memory tiering policy decisions. Let me pause here and let me know what else are there specific items missing. Does the priority make sense?
Yeah, I mean, it looks priority wise pretty good. The monitoring entity is one where we need to, that's where the external interfaces is where a lot of the standardization needs to happen, because that's your entry point, correct, for getting all the information in and out configuration. How do we define that in band versus out of band? Those are the important elements. I think that needs to be hashed out first, in my opinion. Because
You're
without
right,
that, because that's
right,
where the
right,
diversion happens typically.
right, right.
So again, maybe to connect the dots, I think somebody said that we need to see what the device is capturing and how the software is using it. A lot of things captured today is what the device needs to do eventually. But do we also have a list of what is useful for the sake of memory tiering, for the sake of moving data, for example, for taking care of hot pages, cold pages? From the software point of view, what are the things that are needed. So that's what we need to capture. Basically, high level, what is captured, what is stored, and what is communicated. Because the device might capture a lot of things underneath the hood, but then it's too much. Where do you store it? And then which part of it is necessary to communicate with either the application or the kernel for managing the memory.
Right. Yeah. 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 Good. Good.
Go
I
ahead.
think part of that was covered in the previous slide, where a lot of the inputs and kind of the wish list for these features were going to be coming from the TPP paper and the hot page detection and cold page detection from Azure and Google Cloud. So, but I agree. I think, having representatives from the software side come in and say, these are the things that are useful and get those documented, that sort of sets the motivation for this, right?
Yeah. I think if I just to add to that, I think that actually makes sense, right? What interfaces we are providing, what functionality, what interfaces, and how we measure the trade-offs that are happening as much as black box as possible without necessary. And we'll have to, of course, have a discussion how much information inside the device is useful from outside and how much should be left to the implementation. As long as it is observable through API and benchmarks and the metrics.
One clarification,
Feedback.
CMAC, when you mention about what is needed from software or the kernel, you were expecting the API level, because we know our ultimate goal is any page which is accessed, whatever definition we come up with, hot page, that has to be in the near memory to avoid the performance penalty. So that's our, I guess, the basis or foundation of the whole work. So I'm just trying to correlate your comments on, you were trying to define a standard interface for kernel to read, or you're trying to see how we even define the hotness.
Right, how to define the hotness for the sake of it being used by either kernel or the application. And then once we know what those things are, we can figure out the interfaces to it, the APIs, and what mechanism to access it, and how many elements. If they're application level, then perhaps multiple applications running in parallel. So the access method needs to be parallel capable.
Okay,
So those, yeah, again, what do we need? And then later we come up with the mechanisms to provide all of that.
I got it.
Right. So it's the simple as, is it controlled or is it only read? If it's monitoring, okay, who's moving the metadata associated with usage? Is it the host does it? Is it a little piece of code in a host CPU does that? Or do we do that when using some DMA engine as part of the device? Is it stored on the device itself? Is it pushed onto the host memory? Circular buffers that you guys talked about, where is that? All that come a little bit later once we know what the usage model is.
Yeah, makes sense.
Yeah. Very good points.
I think Samak, all good points. Uh, we need some input from software side at this point. I think hardware, the presentation I made earlier, I think we covered the mechanism, at least our point of view on that, and that kind of puts one type of framework for this. But software side, yeah, I agree. If Renu or anybody who is working on hypervisor or kernel level, if you can put together your view, I think that would be the good next step, so that we have heard both sides, right? And yeah, finally it is up
We,
to, yeah.
we can also, yeah, go ahead, Renu.
There is something as part of Project Capital called MMR that is released as a product, which is all the monitoring pieces. Some of it is what's current one. The future ones is not. I mean, I'll try to see if we can get that. What's public information and
That will be good. That will be good.
Yeah.
mainly focus on monitoring.
Sure.
Yeah, and to address the DMA point, right, Sam? I think again we are going little bit into implementation, and if we just keep ourselves at the interface level, I think then people may decide. Some people may go for DMA, some people may not go for DMA. So it's up to them.
Yes, but that is part of actually the interface definition. If the piece of software wants to know what's happening, should they just review something that's in the local memory, or do they need to go to the device, or where data is will eventually determine what the APIs are. So we need to decide what is the most efficient way of communicating the tracking data. Again, underneath the hood, the device can take a lot of measurements, but not all of them are applicable to a particular software need. It needs to be condensed. Once it is condensed, then how do you present it to the host application or kernel? Is it polling? Is it interrupt? Is it
as a part of the interface itself is what you're saying?
Yes, as part of the interface.
Right.
Yeah.
That totally makes sense.
Yeah, the interface definition should cover that. Yeah.
Yeah. Okay.
Any other feedback? Are we missing anything? Major themes or already?
Yeah,
I
I
mean,
think ready.
go ahead.
Go ahead, Manu.
No, I just was going to say also that actually, Redu, it would be good to see if you can have a follow-up on the inputs from software side. Durgesh, I heard you also and would love to hear from you also if you think there is a way for you to bring a view on what interfaces could be or should be. And I'll work on meta side to bring up our software implementation and expectation from if we get hardware implementation of what the interfaces could be. I'll bring it from the meta side too.
Yeah, I'll take that action item and bring it. Yeah.
Okay. Awesome.
Yeah, that will be really cool. Yeah.
Yeah.
I mean, it almost seems like there should be a table somewhere that we have that kind of says for TPP, here are the requirements and granularity and mode of access for gathering the data. For software-defined farm memory, here's what they did. For Pond, here's what they did. And then, and as well as for Project Capitola, what we're doing, so we can figure out whether there's convergence or not, or where some of the discrepancy lie.
Yeah, I think that's a very good way to modulate all the things that are happening and how they are envisioning the interfaces and see if there is a way for us to converge. Is it possible to tee up the VMware discussion next week, Renu?
I'll ask. Yeah, I don't know, but I'll have to get the performance guy to come. Let me ask him and see.
Okay.
Yeah. So Manoj, I'm thinking, these papers too. It's been a while since we actually, tuned into that. I'm sure some of these papers are a little bit old, like Google paper as an example. So it'll be good to actually have Microsoft, Google, and Meta to, bring in their latest perspectives, because these things are evolving so rapidly. It's, and that information could be outdated, and we don't want to depend on stale information to make these very important calls, right? If we can line up those 3 talks as well. And then
I'm just taking down.
I think Windows OS too, right? So Windows OS, I believe we had some discussion in the FDI meetup last year on the Windows OS kernel implementation, how they see the tiering and what is the effectiveness of taking advantage of the memory access tracking. So OS view and hyperscaler view, if we can line up those talks quickly, then we'll have a good way to modulate, recalibrate all these things to create something common that meets the operating system side as well as the hyperscaler side requirements.
Yeah,
I think, Ravi, we should redirect some of the discussion or the presentation too in the way that, here's what we're going for. We want to build some APIs that, whether it be OS or device or whatever. And, we understand that this is what you did for TPP, but what facilities did you use to enable that? So that way we can kind of fill in, understand what people's requirements are, instead of just having to give an overview of the pond paper. So.
Yeah, I mean, we probably have to adjust the discussion as bring in the paper and show the paper content versus, tell us exactly what, the requirements could be based on the current snapshot of the, the work that they have been doing. Right. So paper could be a foundation, but
right.
Right.
Yeah. Exactly.
Yeah, there needs to be a specific proposal so that we can start discussing what that interface should be, and then we can start tweaking from there. At least a baseline proposal needs to be there.
Right. Exactly.
Yeah. Yeah. Okay. Definitely looks like an action item.
Right. So here is the cartoon on how we can actually piece few things together. Again, this is really not comprehensive by any stretch of imagination. I just wanted to kind of visualize the implementation flow, very high level. So let me start off with the CXL memory buffer. We are kind of scoping the discussion to, a simple memory buffer that is directly attached to the platform, right? And it is CXL implementation. So the thought process is that we already have .io protocol that is meant for control plane type of operations. If you were to have an interface, for example, get hard pages as the mailbox command, that essentially provides the visibility into the host physical address space visibility as opposed to the device side of the visibility. Kernel could actually use that information as a way to make, the internal data structures that are currently being implemented a bit more effective, right? So through the kernel implementation, through the device integration, there is an enhancement that we could actually potentially think through. Today, if you were to look at the Linux kernel, there are core paging data structures. There are page flags. For example, Linux actually maintains the page accessed bit, right? So it's very primitive, but to a larger extent. And then of course there are active LRU, inactive LRU lists by the memory regions. A combination of those two are being used for tiering decisions today in the Linux kernel implementation. The question is going to be, how does that existing implementation can be enhanced through the CXL memory buffer interface that provides a lot more visibility into the page access mechanism, right? So that we have to click through and see what does it look like, or does it make sense to actually implement this in the user application and some interface to the kernel, sysfs interface as an example, that it can use to update the core internal data structures on how frequently the page is being accessed. To make the effective tiering decisions, right? So it could be a combination of those two, or it could be completely implemented in kernel. I'm not suggesting any prescriptive, way of going about it. This includes the tracking implementation. So in general, how does the CXL memory buffer actually implement the tracking is something that I think we need to let the memory buffer vendors to innovate in that space as opposed to being very prescriptive. As long as we can standardize on the interface part of that to get the list of hot and cold pages, then that is more than enough from an implementation and integration perspective, as opposed to be very prescriptive about CXL memory buffer need to implement the tracking mechanism in such, with core internal data structures, whether it is circular buffer, hash table, histogram, right? Should it have a SRAM type of capability to speed up in band versus out of band? It's all those nuances we could potentially leave it out to the memory buffer vendor implementation so they can innovate as opposed to being very prescriptive. right? And then you have the user agent. That essentially plays a very key role for the feedback loop, where you essentially monitor the effectiveness of the paging. Let's say if there is a lot of ping pong going on, you probably user agent has to have some intelligence to modulate the configurable entities in the memory buffer. Unfortunately, when we talk about CXLI, the configuration aspects, that's where the implementation that gets closer to the memory buffer implementation. So we have to be very careful on what could be those elements that can be abstracted out. Yeah.
So this is very important. Again, that's why I keep asking, what is the software user model for this? If there is only one entity from the host, one software entity accessing the data that's captured into the CXL device, well, it is somewhat equivalent if that is through CXL.io or if it is just regular memory access to the host memory. However, if the usage model wants to extend this capability to a number of guest OSs, a number of VMs, that are running underneath the hypervisor or such, then having every one of those come across the CXL link to access this doorbell register or such is too much. So that's why I was wondering, again, first asking what is the usage model? Second, figure out if the device pushes this thing only once or if there's a software entity that captures it only once, stores it into host memory in some sort of a circular buffer or such, and then other VMs will locally access it instead of having to come across the link.
Yeah, I agree, Samek. All good points.
Yeah, very good point. Yeah, the hypervisor versus bare metal implementations differ widely.
Yeah,
And so
and
is the
my
case
view
with
is
application based too. If you are doing application based tiering, kernel doesn't actually, and if the application is managing the CXL memory on its own completely, then there is an element of interface that changes, right? So go ahead, Samir.
yeah, my point is especially for the cloud, so many applications, right? So preference is doing it in hypervisor. Doing
Yeah.
it in guest is we are asking too much from many vendors, right? So
Yeah, that's what
Yeah.
I thought. It's always hypervisor because even guest we don't even know. There are two levels of translation. One is within the guest and then at the hypervisor level. So guest may not even know how to access that memory or how to start moving the pages and so on and so forth.
All right. Right. Yeah. Yeah. That will be the single entity, the hypervisor or the barebone operating system kernel, one of those two, to essentially keep track of the access patterns, right? So the single authority to essentially, provide that information to whoever wants to consume.
Okay,
Yeah.
so this is a major decision. If you guys believe that's the case, let's write it down and move along that path because that simplifies a lot of things.
Right. Right. Let me capture that. Very good feedback, Samak and Durgesh. Okay.
One more question I had regarding this granularity and page level access, right? So Linux is moving towards variable sized compound pages and folios, right? So is that something you want to consider and talk about memory objects?
I missed that, Rekha. Memory objects, you said?
Yes, considering that Linux is moving towards folios and compound pages and variable sized pages in that sense.
So you're talking about the granularity of the page, and it could be a variable length, and how do we ensure that we can reconcile that between what the tracking happens inside the memory buffer versus the operating system, like
Yes, and
emerging
how does
implementations in the Linux kernel?
exactly? So
The, the,
is it
the,
going to be page level? How is the Linux steering mechanism currently handling it? Is it going towards folios? Will it match, or is everything evolving too separately, too fast?
So looking at this problem from the device's point of view, the ritual to physical mapping has already been done. The device is seeing memory cycles coming to it. It doesn't know what type of a page size you selected. So from the device capturing, perhaps the physical things they capture will be fixed. Maybe, I don't know, pick 4K pages, 256 bytes, whatever you like. That's what they finally capture. And then that was what I was saying earlier, that it needs to be translated somehow, either by a little piece of code running on this CXL device or by the kernel itself, translated into this page sizes and such that the kernel has decided. That's the way I've been thinking about it, but I don't know about the rest of the team, what they think.
Yeah, I mean, if the problem with the settling on any specific page size is essentially influenced by the operating system kernel or VMM implementation, right? So we'll have to essentially pick certain granularity for the device to implement from an interface standardization perspective. Um, you know, for example, 4K. If you say 4K, that is essentially the the granularity at which you essentially get the data from the device. The actual mapping of what that 4K entails in the core internal data structures, if it is a variable length page, or if it is a huge page, we have to leave it to the kernel, right? Otherwise, if we get very close to the kernel implementation, like Linux kernel, then it is essentially it's not going to be common, right? So we'll have to achieve some commonality, and we may have to pick certain page size. Of course, it can be configurable too, right? So that's the discussion we need to have through the policy type of updates, right? That says, hey, I prefer this page size, and during the initial bootstrapping, use that as a way to configure, and that will be your granularity at which get hard pages get reported from the memory buffer.
But Randy, you're talking about granularity at the HPA level, not the DPA level, or are you talking about the DPA level?
HPA. Because
Right.
no one will have visibility into the DPA behind the scenes. Neither kernel cares about DPA. Yeah.
Right. So again, the device captures certain things, and then the host eventually decides what to do with it. Some of the things to do with it is moving memory. And you guys can decide at what granularity will the move happen. So
Right.
uh, if the
Yeah.
move is at a page, and by that point, the host knows what the page size is. So they move it based on page size that the host knows. But the device doesn't know. Probably it's too much to ask them to know what page sizes are. Therefore, from the device point of view, it captures things on physical boundaries, maybe 4K or 1K or 256 bytes
Right.
might be useful.
Some aligned pages. Yeah. 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 Yeah.
Right.
Exactly.
So to just sort of double down on that, I mean, from the memory buffer perspective, I understand the need to allow the user agent to program a tracking size, but I just want to make sure it's clear. We would also embed in this the ability for the memory buffer to advertise what granularities of tracking it's capable of running at, right? Because
yeah. Good
incredibly
point.
large
Yeah.
capacity
Yeah.
devices, 4K might not be reasonable. But do we say it's 4K or nothing? Or so I just want to make sure that there's a lot of these capabilities. The device has the ability to advertise its level of granularity. So we would want
Yes.
I would want to empower device vendors to be able to use that as well.
Yeah. Very good point. I
Right,
think.
Vince.
Yeah.
Vince, as you know, very similar to our visual capability, our human capability, this thing might have to do with some sort of a logarithmic scale. In other words, the capability should be such that fine things can be captured, but not all things will be at a fine level. If
Mm-hmm.
if hot pages, well, all of these things are hot. Well, what do I do with them? Well, move the whole thing. In that case, you just move the whole thing in one shebang. But when you get a little bit finer, maybe within a 4K boundary, an app might be very busy on one cache line, not the whole 4K. Now, what do you do with it? Do you move the whole 4K? Do you have the capability to do that, or do you have the capability to move
Right.
only a portion of it?
Right.
So this is for hot and cold assignment. It is also for use. Maybe the buffer is being wasted. It's not used at all. So in that case, maybe we come up with different techniques of consolidating things that are not used, basically removing all the bubbles. All of these need to be kind of described, and yeah, granularity is a factor.
Yeah.
Yeah, there is a
I
very
will
Yeah,
say
so there
also,
has to be some handshaking mechanism. Like, yeah, agree. Yeah, that's
exactly,
a very good point.
exactly. Some kind of handshaking. Discover the scope of capabilities. Yeah, for tracking as well as movement. I think that's a good point. Um, Uh, I
So
don't
as
want to
we
get overly pedantic early on, but I do think there were some good points from the last discussion about this on the naming of it, because the device, the determination of hot versus cold is relative, and it's really up to the host to figure out what that means. So the device actually is not able to make a determination of hot versus cold as far as the system is. It can know its access tracking. So I think that the title of the presentation is very apt. Like the memory buffer can track accesses to capacity that it's responsible for, but it can't actually make that determination of hot and cold. So I'm wondering if it would be useful as opposed to operating with the concept of a get hot pages command, if we soften that language a little bit and focus it more around what the device is actually doing, which is
Vince,
just tracking access.
Vince, actually, I have a different point of view here.
Hmm.
I understand that software guys are going to be very busy doing whatever they need to do on host to do the high level memory tiering capabilities. They have a lot of work to do. I'm expecting CXL devices to, in hardware, capture a lot of things. And as you
Hmm.
know, CXL devices do have controllers running on them. That controller can consolidate things based on whatever it has captured and
Hmm.
make meaningful insights out of them. And eventually, through this conversation we're having, we will determine to what extent the insight from all the detailed capture can be turned into an assessment of hot versus not. Therefore, it's simpler kernel to say, oh, okay, these are the pages that this guy tells me I need to move. I'm going to just move them right now. I don't have to worry about it. If they want to worry about it, we can provide access to the full data and then deal with it on their own. But if the work is done by that little controller that's in there, perhaps it will serve us all best.
Yeah.
But
as we
so when we say move them, when we say to move them, so um, uh, the flow at a high level is the buffer is saying, here's a list of most frequently accessed pages, and the host is going to look at that list, and it has higher performing memory somewhere, and it might determine that uh, based on how frequently these pages are accessed, I need to move this memory to a more performant media. Um, uh, that's a host decision. So um, it's still like all the memory buffer can do is say, here's what's here here's what's most frequently accessed for me. It's not seeing the other media types, the other activity in the device. So it's not actually, I don't know. I guess I struggle with the relativity of the word hot. Um, if we did truly want to stick with the concept of hot, and the memory buffer is explicitly reporting out, here are the quote hot pages, which is to say, um, it may not be reporting all of the most frequently accessed pages. Like it would need to be programmed up with, here's the criteria for hot. Like I would want that embedded in the control structure is here's the frequency pattern, the number of hits per monitoring cycle, like however that gets codified, so that the buffer could in fact do that, but that runs the risk of, if that criteria changes, the host needs to go out and reprogram all the devices to say, well, that used to be hot, but now it's cold because there's a lot of other activity going on. Or
Right. You're right that we have to define what hot means. In the past, we talked about spatial and temporal aspects of it.
mm,
So let's
mm-hmm,
just say we eventually figure out what that is. But what I see happening eventually from the hardware guys' point of view and moving data to reduce the amount of data that we need to move for the kernel eventually or this application to know what to move. A lot of detailed work has to be done by the device, and that can be done locally without going across the CXL to waste the bandwidth and power and other things.
mm-hmm.
So I don't know what those things are. We will eventually define them, but I see that work needs to be done locally. Lots of things get captured by hardware registers, and then a little piece of code.
Mm-hmm.
Every one of these devices has a controller. Can go periodically look at it and update the hot and whatever list based on the policy that we will eventually define, and maybe kernel guys will happy with that kind of a assessment. If the kernel guys are not happy with that assessment, we will provide a full shebang of data. You say, hey, you want to go read it, but you have to move all the data all the time, and you have to do the sampling across the Excel link, and there's a lot of data
Right,
will move across the Excel link.
right.
So I like us to have the mechanisms, and later software guys will decide which one is best for them.
Yes, so
No,
CMAC, the last
I
part
think,
which you
yeah,
said,
yeah.
that's what I would imagine, that we just collect the data, like as Vince was saying, maybe it's the frequency that these many times this cache line is accessed, but we leave it to the hypervisor or the host to decide how frequently it will look at the data and when it will move. We don't, as that endpoint device, don't decide when it's hot page, when it's cold. We just provide the data, let the host decide it. And the data
Well,
movement when you're talking, this metadata is small. We're not moving the page. We are just passing on the metadata.
well, I can see the
Quick,
argument that if part of the goal of this is to offload some of the work that the kernel would need to do, then it would be helpful to provide, uh, generically speaking, instead of narrowing in on determination of hot versus cold, it would be helpful to allow the host to say, to control the amount of data that's reported out, so that the buffer isn't always just reporting, like, I don't know what the number is, but to make something up, like, here are my 128 hottest pages. Giving the host some sort of controls to say, only tell me about a page if it hits this threshold of access, and something like that. And you could call that a hotness criteria, or you could just call it a way to decrease the amount of traffic. But if we're
Yeah,
trying to
that's the
offload the
register setting
CPU,
though,
yeah,
Vince.
yeah.
The VM will do the cxl.io register setting, so which can say, I need these kind of settings, and you can define the registers which are written. Um, but
Okay.
but the
Yeah,
device
I
need to
think
I think
define
that's
whether it's
in,
hot or cold.
yeah,
The
we are
I
all
think in
latency
general
thinking
has
the
the
to be
same
theme
page, I
reduced.
guess.
is so I think in general the theme is that the memory buffer actually reports. We can figure out the
Yes.
name, right? I'm not hung up on get hot pages or anything, but in general, when the memory buffer reports, we have to pay attention to a couple of things. One is uh, this is such a high in a very active system. This operation is probably pretty frequent, right? So we can't actually take a brute force approach and say if you have a terabyte worth of memory buffer capacity, or a few gigabytes worth of memory capacity, you kind of give a map of all the pages and how the access pattern. Let the kernel actually filter it out, right? This is what CMF was pointing out. So we somehow have to strike a balance between lightweight, interface that doesn't really that essentially feeds in pretty much what kernel needs, so it doesn't have to make the decision on its own every time it makes a call. To that extent, we have to figure out what that means. And then there has to be a configurability element, right?
I'm sorry, but I'm a little
Um,
uncomfortable with that. The reason is, how do you scale? Right now we're talking about extension, but CXL is very active in pooling and others. And the moment you leave it to the hypervisor or host, now you have multiple hosts and you cannot scale. So somehow we have to focus on the device independent of host, as there are multiple hypervisors. All those things are very different.
Right.
so, so
Guys, I'm noticing that mostly the hardware guys are talking, and we're here as software hardware co-design. And this one has a lot of software elements into it. Software guys, would you please pitch in?
yeah, we have to pay attention to that. Yeah.
So at least
Go ahead.
I will definitely have the meta present either next week or week after next, so that I think we are agreeing on most of the things. There are the details that we have to get through, that we can make sure of. Some of those, as Reddy said, we had put it in our paper, but things we have to make sure that they are evolved and where they are evolved, and what functionality that we had done at a user level implementation that used the existing one and did the software based implementation. If we start using this capability, how that would change. So um,
Yeah.
I don't think I have something that I can add in a 1 minute right now, but we'll have a full presentation either next Wednesday or week after that.
Yeah, I think
Just
let's tune into the software side of the view,
Yeah.
not just the device side
maybe
of the
can
view,
you
and see
send
what
out
makes sense, what doesn't make sense. But in parallel, me and Samir will continue to refine this as a click-down implementation flow by taking Linux as an example, right? So we have to get to that level as well in parallel. So we'll keep this as two parallel activities, to figure out, and we can continue to refine.
Yeah, I know,
Go
Rekha,
ahead.
you're saying something, I think, but just give me 1 second and say, this is actually good discussion from our process perspective. This is what we will do, right? We would like to get this contributions for anybody who has a proposals or suggestions for changes. If you can send actual something which is in the slide or document that you want to, so that we can have specific discussions and debate pros and cons. That will be actually very useful. Discussions are great, but also putting something down will help us to actually come down much more closely.
Yeah, and Durgesh, please send me the details. Me and Samir. Looks like you
maybe
have very strong feedback.
template
Right?
table on
We'll be happy to listen. Take a look at that. Right.
Sorry, Rekha, go ahead.
yeah, if ready, you can send out a template table on what you expect from the different software folks, like granularity or what is the access frequency or recency or whatever that different vendors are interested in or different software folks are interested in, different companies can fill out. That will be helpful. So we don't miss out
Okay,
the different.
Rekha, yes, we will work on few suggestion agenda topics for next follow-up meeting.
Okay.
Yeah.
Awesome.
Maybe we could essentially create a question template. They can address them specifically too. Yeah.
Perfect.
Okay.
I think
Good idea.
this is good. I know we are. Yeah. Sorry, go ahead.
Last question. So does this
Yeah.
also cover the interleaving weights and interleaving granularity?
No. I thought about interleaving. In general, I'm not the moment you bring in interleaving, what it means is that I somehow think that if you can actually stick at the host physical address level, you may be okay. I still need to think through, but do consider that and see if you need to actually incorporate the interleaving mechanism, because that kind of device interleaving or the host interleaving, right? I want to be agnostic to either one of them if possible. That
I'm
gets
looking
into a
at
very,
this.
very simple
Yeah.
implementation.
That's one of the reasons I was suggesting that maybe the device has to capture things below a 4K, because if it is interleaved, maybe a 256 bytes is a representative of a page, or something equivalent, depending on how many interleaves you have.
Right. Yeah. Yeah. Yeah.
So
We do need to pay
I
attention
think
to
most
interleave
of
though. I thought about it, but yeah, in general,
Nick,
it's a
so
very interesting
by
I
topic.
feel
the way,
I feel
we
that's
are
missing Reddy here. Yeah.
we're at an hour, but I think this is a great discussion, good progress. Can I also request for us to start getting active on the email so that you can send out emails and have this discussion going on? We don't have to be limited to this 1 hour only. And also, please do send in plans so that if you have a presentation or requirement that you would like to add into this discussion, it will be really good to get those. Even the email is fine. We can start from the email, but if it is in the document, send it out so that we can schedule for the next week's call. So we have bunch of
Did you say
action
there
items
is
that we
Slack
take on.
already, Manoj,
Sorry,
where we can have these types of discussions? Slack channel.
we don't have Slack
Email
channel.
will be not effective, right? So
Yeah, we don't have Slack channel right now, but we can use emails. If you are not the
okay.
OCP email distribution, I hope all of you are
So
on the
just use the
CMS
distribution.
distribution. Yeah, distribution list. Let's use at least the distribution list, distribution, and then
Okay.
we can start from there. But that and presentations, documents, that will be good. I'll send out an email where the public folder is. CMAC had a problem accessing it. Please to check whether if you have access problems. If not, we can put the document. Let me make sure that we can put the documents directly into that public folder so that everybody has access, so that you can start discussing it. But this is all going into that one section contribution that we want to do from the hotness indicator as we define the overall system architecture specification.
Yeah. Great feedback.
Right.
Thanks, everyone. Yeah.
Hey, thank you very much. Thanks. See you guys every next week.
Thanks.
Yeah. Thanks.
Bye.
Bye.